Welcome viewers. In this video we are going to do design of a bitumen top road section using IRC 37 1984. IRC 37 1984 is now it's a withdrawn code, or we are having a latest version of IRC code in 2018. But most of the project, especially in substation project, we used to follow IRC 37 1984 for road section design in bitumen topping. Let me look into that calculation. In the left hand side you can see an Excel sheet about the design of bitumen top road section using IRC 37 1984, and in the right hand side you can see the PDF file of guidelines for the design of flexible pavements IRC 37 1984. So with these two sources along with the geotechnical investigation report about the California bearing ratio, we are going to do this calculation for road section for bitumen top peaks. So the CBR, the California bearing ratio, which is mentioned in the geotechnical soil investigation report, we can assume as a 7%. Generally, it starts with the 5% to go up to 20% or more than that. So the more value of CBR percent will give you the reduction in thickness or the overall filling of the road structural elements. So it means that CBR is inversely proportional to the thickness, total thickness of the pavement. So let me look into that the detail about this calculation, and the considering the as per the technical specification that it is mentioned that we can assume that there is 150 numbers of commercial vehicle per day will move on the road in terms of a traffic range. So corresponding to that we need to go to the page number 15, that is the table 2, which will provide you the traffic information which is to be considered. Accordingly the thickness, pavement thickness chart we need to refer. So here you can see on the right hand side PDF file table 2, classification of a traffic for design. So the commercial vehicle per day as per the technical specifications we assumed is 150 commercial vehicle per day. So the accordingly the CBR design curve is applicable is C. So this information we can get from the page number 15 of IRC 37 1984. Also we need to find out the standard axles value. So for that page number 11 to be referred. So here you can see a table. So design traffic of 150 commercial vehicle per day is graph ABC we need to refer up to 0.5 million standard axle. So we are assuming here 0.5 million standard axle is our technical requirement to find the pavement thickness. So in order to find the total pavement thickness we need to refer page number 8, that is figure 1. So here is the chart which is showing the total pavement thickness required based upon the cumulative standard axles and to the CBR value. So as per our geotechnical investigation we assumed the CBR value is 7%. So this curve we need to consider, and the cumulative standard axle is we are considering 0.5 million standard axles. So this we are drawing a line, vertical line at 0.5 MSA, and from the graph 7, so this is a portion which is touching. So the total pavement thickness required for this combination of CBR and the CSA is 315. So we are entered here 315 as the total pavement thickness required. And coming to the figure 2, that is just in the next page. So here will explain what is a thickness required for this kind of traffic input and the CBR value. So for MSA, that is accumulated standard axles, CSA 0.5 million, we need to provide 20 mm PCC, a bitumen coating premix carpet we need to provide. So we had provided the 20 mm, and the base and WBM we can provide as 150 mm in 3 layers of, it should be 2 layers of 75 mm, and the thickness for subbase is required is 150, minimum thickness is 100 mm on subgrade of CBR less than 20. So CBR less than 20 we are going to consider, but the minimum thickness is asked for 100. If you consider this 100, then this will not satisfy the figure 1, which is a record total thickness as a 315. So we are just increasing this to 150. Now it is stating safe. So instead of having that 150, which is a 98% as a utilization compared to actual total pavement requirement thickness as per the figure 1, so we can increase this little bit more. Instead of considering this 98% of usage, we can increase the thickness as 200 mm. So 200 mm granular material of CBR not less than 20% we are considering in 2 layers of 127.5 mm thickness. So this 125 mm means it is a uncompacted thickness. So while doing the compaction, it will come to 100 mm each layer, so that these 2 layers of 100 mm will match these 200 mm of thickness. So thus the thickness, thus the structural components of the road section we have decided. So then the total thickness we can add 20 plus 150 plus 200, in total it is 370 mm, which is greater than the required thickness as provided in the chart 1 with respect to the million standard axles and the CBR value. So hence it is safe, and this is a small sketch about the road thickness. So we are keeping a slope of 1:50 in order to drain out the stormwater on the road, and subbase courses is 200 mm. Above that, water bound macadam is 150 mm, and finally the bitumen premix carpet of 20 mm thickness is provided. So this is the road section thickness definitions as per IRC 37/1984. We will look more about another version of IRC 37, that is the latest one 2018, which is having some of complicated calculations. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.